Okay, so the first thing we have to do is fill in this blank at the top for the definition of a monomial. So a monomial, that is only one term, okay? Terms in this class, they are separated by addition and subtraction. So a monomial is only going to have one term. So we're going to write one term. And then that one term, it could be a number or it could be a variable. So it could be a number or a variable. Or it could be the product of numbers and variables. Okay, so it's got one term, could be just a number, or it could be just a variable, or it could be a product of numbers and variables. So let me write down a couple of examples for you guys. So it could be just a number, so it could be something like -7. It could be just a variable, it could be like x to the 4th power. Or it could be a product of numbers and variables, so it could be like 3x squared y. So there's 3 examples of monomials. And then the degree of the monomial is the sum of the exponents. All right, or the sum of the powers. So let's do examples 1 through 3. So on example 1, if you want to know the degree of this monomial right here, this 4p to the 4th, q to the 3rd, well, you have to sum the exponents. So you're going to add these powers together. So the degree on this one is going to be 4 plus 3. So the degree is 7. Well, then on number 2, there's really, and it's implied that that's e to the 1st and d to the 1st. So if you're going to add those powers then, so you're going to add these powers. So the degree of number 2 is going to be 1 plus 1. And then on number 3, well, that's just a number, right? They call that just a constant when it's just a number. But that's really 3 times x to the 0 power. Well, what's x to the 0 power? What's any number to the 0 power?
1.
I couldn't hear you. What was that, Ethan?
Is it 1?
Yeah, it's 1. So really, that's just the same thing as 3 times 1. Well, you can see then the degree there then is going to be just this power right here. So that term or that monomial has degree of 0. So the degree is equal to 0. So if it's just a number or just a constant, the degree is 0. And the next thing we got to fill in there is we got to fill in the definition of a polynomial. So a polynomial is more than one term. And then those terms will be separated by addition and subtraction. So So this is more than one term. So it's really the sum or difference of monomials. So the sum or difference of monomials. And again, by sum or difference, I mean addition or subtraction, okay? So it's going to have more than one monomial added together or subtracted. All right? So then the degree of a polynomial, so we want to know what the degree of a polynomial is. It's the highest degree monomial. So you're looking for the highest power term. That will be the degree of the polynomial. So if you look at number 4, well, the highest power term is right here. So that means that the degree is 7. So this one is degree 7. All right, well then on number 5, you got to look at each term and decide which one would be the highest power term. That will give you the degree of the polynomial. Josh, I need you on camera. Thank you. So if you look at the first term here, you've got w to the second times z to the first. So the degree of that first term, well, you got to add the powers together, right? If you've got two variables multiplied together, you have to add the powers together in order to get the degree of that term. So this term is, that degree of that first term is 2 plus 1. So that's degree 3. And then the second term, well, that one is degree 4. And then the third term, well, the third term is just negative 5, so that's a constant, so that's degree 0. And then again, the degree of the polynomial is the degree of the highest power term. So the answer for this one, the degree of that polynomial is going to be 4. Okay, so that one's degree 4. This one is degree 7. Well, then the next definition we have is we have to define what the standard form for a polynomial is. So if you want to write a polynomial in standard form, you want to write the terms in descending powers. Okay, so I'm going to write Standard form is going to be the terms are in order. So the terms are in order from greatest to least degree. Okay, so if you look at number 6, you just got to write it in order with descending powers. So your highest power term is going to go first. Now, if that term happens to have a subtraction symbol in front of it, then that subtraction needs to go with that term as a negative out in front, okay? So if you look at number 6, my highest power term is right here. It's the negative 7x to the 5th. So that goes first. So it's negative 7x to the 5th. Then my next highest power term would be x squared, or the term with degree 2. So that would be plus 4x squared. And then my next highest degree term would be degree 1. So that would be plus 6x. And then my last term would be my 0 degree term, which was my constant. That's 9. That's a positive 9, so it's plus 9. So that's what it means to put it in standard form. You just write the polynomial with the terms in order from highest degree to lowest degree. And then the other thing I'm going to add in right here, it's not in these notes, but it is in the assignment, is you need to be able to write down what the leading coefficient of the polynomial is also. So the leading coefficient is just the number that's out in front of the highest power term. Okay, it's the number that's multiplied times the variable in the highest power term. So in this case, it's just going to be negative 7. Again, so the leading coefficient is just the number out in front of the highest power term. Well, let's write number 7 in standard form. So my highest power term would be y to the 4th. Oh, sorry, y to the 6th. So my highest power term is this one right here. That's degree 6. So we're going to write that one first. So that's a positive y to the 6th. And then my next highest power term would be, that's a positive y squared. So you're going to write plus y squared. And then my least degree term would be it's a minus 3y, so it's a negative 3y. And then on this one, my leading coefficient would be the number out in front of my highest power term, which would just be a 1. So I'm just going to write LC for leading coefficient is 1. All right, then the rest of this, we got to fill in these 2 tables. This is just vocabulary stuff. So there's a lot of vocabulary in this section. So let's fill in these two tables. Okay, so if we're We're going to classify the polynomials in two ways. One is by their degree, and then the other way is by the number of terms. So if the polynomial is of degree 0, it's called a constant. If the polynomial is of degree 1, it's called linear. If it's of degree 2, then it's called quadratic. If it's of degree 3, it's called cubic. If it's of degree 4, it's called quartic. Degree 5 is called quintic. And that's as far as they go in terms of naming them by their degree. So if it's got 6th degree, they just say it's 6th degree. If it's got 7th degree, they just call it 7th degree. So that would be naming the polynomial by its degree. And then by its number of terms. If it's got one term, we've already said that's called a monomial. If it's got two terms, it's called a binomial. If it's got three terms, it's called a trinomial. And then if it's got four or more terms, they don't have a name for it. They just call it a polynomial. But be aware, a monomial, that's still a polynomial, okay? A binomial and a trinomial, those are still called polynomials. All right, so then on, let's see, what do we got left? On 8, 9, and 10, we got to classify these polynomials by their degree and by their number of terms. Actually, let me get this where you can see the chart here also. There we go. Okay, so let's see. The first one here. Here's our polynomial. So it's got two terms. Remember, two terms are separated by addition and subtraction. So it's got two terms, so it's a binomial. And then, what's the degree on number 8? Somebody's got to unmute.
Is it 3?
Yeah. Yeah, the highest power term is got a 3, right? So it's degree 3. So it's called, for degree 3, it's called cubic. So then we're going to write down that one as a cubic binomial. So it's a cubic binomial. Okay, then the next one. So let's see, this one has got, again, it's got, well, you guys tell me, number 9, how many terms does it have? So how many terms on number 9? Again, terms are separated by addition and subtraction. Jackie, you got it?
4.
Yeah, it's got 4 terms. So so this one right here, it's got 4 terms. So we're just going to call it a polynomial. And then, what's the degree on that one?
I think it's 6.
Yeah, good. Yeah, the highest power term is 6, so it's degree 6. So it would just be 6th degree. So we're just going to write that it's a 6th degree polynomial. So 6th degree. So by classifying it by degree, it's 6th degree. And classifying it by the number of terms, it's a polynomial. Okay, then number 10. Hopefully you guys can see that it's got 1 term, right? So this one has only got 1 term. So that is a monomial. And then the degree, well, the highest power on the variable there is 1. It's x to the first power. So that means that it is degree 1, so it's linear. So this one is just a linear monomial. So number 10 is a linear monomial. All right, so we only got 1 more to go and we're done for today. So the last one's a story problem, but it's really not much of a story problem. You just got to plug a number in. So let's look at number 11. Okay. So it says the height of the Golden Gate Bridge is 220 feet above the water. And then the height of an object, if you drop it off of the Golden Gate Bridge, would be given, the height would be this function right here. And the height depends on the time. So they want to know how far above the water will an object be after 3 seconds. 3 seconds after you drop it. So really all you got to do on this one is you just got to take the 3 that they gave you here, and you're just going to plug it in for the time right there. So just plug in 3 for t. So we're going to write the height after 3 seconds is going to equal negative 16 times 3 squared plus 220. And that'll work for any object, as long as it's not like a feather or a piece of paper or something that's going to have wind resistance. So then now what do we do here? Do we square the 3 first, or do we multiply by the negative 16 first? There's a multiplication right here. So again, what do we do? Do we do negative 16 times 3 first, or do we do 3 squared first? What do you guys think?
3 squared first.
Yeah, good. Yep. Yeah, by order of operations, you have to do exponents before you multiply. So we need to do the 3 squared first. So we've got negative 16 times, well, 3 squared is 9, and then plus 220. Well, negative 16 times 9, that's negative 144 plus 220. So what does that equal? 220 minus 144? That's going to give you 76. So the height after 3 seconds is going to equal 76. And I think you guys can see that the height here was given, the initial height of the bridge was given in feet. So this answer is going to be 76 feet. Again, so ignoring wind resistance, if you drop a penny or a bowling ball, it doesn't matter, off the Golden Gate Bridge, after 3 seconds, it's going to be 76 feet above the water. And I think that's it, right? I think that was the last thing, yep. So let me stop my recording here.